Okay, 5a, they already had a common denominator. They already had one. So all you had to do is subtract and add the numerators.
Wait, I need to see this.
7 minus 3 plus 1 is 5. 5 over 5x cancels. The only thing that was a little tricky about this problem, and that I think your book was probably trying to get you to do, is to figure out what to do with that x. You have to keep in mind that it's in your denominator, and when you cancel out 5 over 5, you get a 1. So it's 1 over x.
Wait, why would you cancel out 5 over 5 because they're not the exact same thing?
No, you cannot do, you could do x to the negative 1 power if you wanted to, but I don't know
Like,
why you
let's say
would.
x was 2, then it would be 5 over 10. So then you would cancel. So then
Yeah, you would. So guys, yes, if you leave it 5 over 5x, that's wrong. Okay, you're not going to lose all the points you'd lose if you wrote, 21 over 5x because you multiplied the numbers. Yeah.
That's mine.
No.
Like a math book?
I think
I have one in my locker.
Yeah, so I mean, if you leave it 5 over 5x, as far as I'm concerned, that's wrong. That's like writing an answer of 2/4. You have to simplify as much as you can. Okay. B, you had a common denominator, but you didn't need one, actually. They were trying to trick you here. They were trying to get you to write 5x as your denominator. But you should not do that because it's multiplication. When you multiply, 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 multiply. Multiply, multiply, multiply. You should get 21 over 125.
oh, that's all you do in that one?
That is literally it. There's nothing else you can do. Nothing
Okay.
simplifies.
Yeah,
Mr. Oh, sorry for the next one. I got a totally different answer.
Okay. Are we on the next one now?
Yeah, are we on D now?
No, we're on C.
Oh, sorry.
Okay. I didn't know which one you meant by next. Okay. These already have a common denominator. Okay? So you write them together, okay, over the common denominator. This is probably an answer that a lot of people have.
I had that.
Okay? If you had that, you miss one step. You have to try to, once it's one fraction, now try to simplify. If you take out a GCF of 3, you're left with 2a minus b in both your numerator and denominator. That cancels out, and you just get 3.
That's the one I'm really confused on because I got, for that one I got, for that one,
Are we on D now?
I got 9 minus x squared over x minus 3. Like, I didn't get how she got that at all.
Okay.
Whoever-
Let me kind of show this a different way for D. Okay. So for D, we're all good with, I'm hoping, with getting 9 minus x squared over x minus 3. Yes. It's a common denominator. Write them as 1. That's it. What do you need to try to do after this? Simplify, right? So you need to try to factor in order to get it to simplify. Lauren's right. This is difference of squares rule, except it's backwards. Okay? What Lauren did is she took out the -1 first. Or she wrote it in a different order and then took out a -1. And I think maybe just the way she wrote it was a little confusing. It's really simple. This is difference of squares, except the numbers go first. It's 3 minus x times 3 plus x over x minus 3. Which of these, none of these match right now. But which of the two can we get to match? Kara? X minus 3 and 3 minus x. We just need to take out a -1. So take out a -1 from, I'd go here, but it doesn't really matter. -1. Now this turns from 3 minus x into -3 plus x. And now, even though they don't look exactly the same, the 3's are both negative, the x's are both positive, we can cancel those out. And then what Lauren did at the end is, when she had that -1, she did distribute it back in, and you get -3 minus x. You don't have to do that, but you can. Kara?
Okay, wait, the -1 that's like right there, do you just leave that? Like on the front, before the parentheses?
Correct.
Okay.
Yep.
So it's just -1.
You leave that, so you could,
So do you also
you could
distribute that
leave
to
it
the-
right here. After you cancel, you can just leave it right there.
Yeah,
This
that's
is a good answer, but you could distribute it back in. Yeah, either way is good.
Okay.
Either way is good, yeah. Okay, anything else on that one?
Nope.
Okay, E. So this one, I'm hoping.
I thought you could factor it, but then.
No, you can't. Yeah, you can't. So hang on, we're gonna talk about the end of this one real quick.
Wait, is that a 2 or a 3?
That's a here.
No, x.
X cubed. Okay, so I'm hoping people figured out that your common denominator is x cubed.
Yeah, I did.
Okay, that's good. So if this denominator is x, it needs 2 more x's, so multiply by x squared, multiply the middle one by x, and the other one you don't have to multiply by anything. okay? Then when you combine, you get this. Now, I believe you can factor this. I believe you can factor that trinomial.
That's what I did.
But why is it unnecessary to bother with that factoring? Does anyone see why it's not going to help us to factor that trinomial?
Because you're not trying to get any further in the problem.
Why? How do you know we're not trying to get any further?
Because you have an
can't
answer.
cancel it.
Well, that's not why.
Because it said simplify, it said do the problem with simplify.
Right, but that's not why, actually, no. Because you see, here's the deal. If we had, let's pretend for a second, let's kind of ignore the rest of the problem. Let's pretend that you were at a point in a problem, not necessarily this one, but in a problem, and it looks something like this. And there was an x minus 1 in your denominator instead.
Oh, because you can't.
Oh, you can't cancel it.
You don't know if you
You
can
can't cancel it.
You don't. So here's the idea, right? For this one, you don't know what this is going to factor to. Could it have it potentially an x minus 1 when you factor?
Yeah, but it
Yes,
can't because
it could. But if you have x cubed on the bottom, is there any way whatever this factors to is going to cancel with x cubed? No, because you need a GCF of x or x squared or x cubed. You need something to come out that was just an x by itself. It's not going to cancel. So there's no point in trying. But if you did, it certainly wouldn't be wrong. Where are we at time-wise? We about done?
Yeah.
We're like
Okay, really quick. This one is pretty straightforward. You just have to factor, cancel, and there is one of those -1 things. Tomorrow we'll start by going over the long division problem number 6, and then we'll review the rest of class. Okay?
I quit. I quit.